Hi, this is Ms. Park. This video is about simplifying rational expressions. We're also going to cover multiplying and dividing rational expressions. Look for an upcoming video on adding and subtracting rational expressions. So we'll start with what is a rational expression. So the word rational refers to, same as a rational number, it refers to a fraction. So a rational number, some examples would be any kind of fraction, so like 1/2, 3/1, so like a whole number, 10/65, so anything that can be written as a fraction, including things that have repeating decimals. So for example, 1/3. Right? That would be a rational number because it can be written as a fraction. Some numbers that are not rational or irrational are numbers that cannot be written as a fraction, like pi. Pi cannot be written as a fraction, or some of our radicals, like a radical 2 or a square root of 2, cannot be written as a fraction. So when you have a rational expression, it's not numbers in the numerator and denominator, it's algebraic expressions that can be written as a fraction. So if you look at some of the examples a little further down in the page, you've got a fraction, but you've got algebra in the numerator and the denominator. The thing with rational numbers, or things that can be written as a fraction, is that we have a restriction on what the denominator can be. All of these irrational numbers are defined, but what is undefined is a fraction that has a 0 in the denominator. So anything in the numerator is fine, but in the denominator we cannot have a 0. And so this number is undefined. If you put it in your calculator, you'll get an error. Division by 0 gives you an error because we don't know how to divide something into no groups. So so that is an error. Same thing with algebra. So I'm just going to take you through this course pack page, and we're going to simplify some of these expressions. So we'll talk about restrictions as well. So we'll look at A, and for A, we're going to look at how do I simplify this? So how do I reduce? So with numbers, we can reduce. So if I have, for example, the fraction 4/2, I can say, well, 2 is a factor of the numerator and 2 is also a factor of the denominator. So I can write this as 2 times 2, and I can write this as a 2, and I can reduce the factors. And so this will reduce to 2/1, or just 2. Okay, same thing happens with algebra. So I see that there are x's in both the numerator and the denominator. So what I should do is I should factor whatever I can. I notice that there is a common factor in the denominator of 2x. So I'm going to factor out the 2x, and I'm going to get inside x minus 2. And now I'm going to notice that I have an x and an x in the x in numerator, x in the denominator, and they will reduce. Before I reduce, I have to do something else. I have to look at this expression and say, all right, I have this fraction, but this fraction may be undefined depending on certain values of x. So before I can write this fraction and work with it, I have to say what x is not allowed to be so that this fraction will never be undefined. So let's look at the denominator. What will make the fraction undefined is what will make the denominator equal 0. Let's look at what's in the denominator. What values of x will make this denominator 0? Well, this is just like solving the quadratic equations where we had the factored form, and we're looking at trying to solve it, see what values of x make the expression 0. So I can see now that if x was 0, then 2x is 0, and the whole denominator goes to 0. So x cannot be 0. And also I can see that if x is 2, then this bracket will go to 0, which makes the denominator 0. So what I'm going to say is I'm going to work with this fraction, but I have restrictions on x. X is not allowed to be 0, and x is not allowed to be 2, because if it was, this fraction would be undefined. So this, what I'm writing, is called a restriction. It means x is not allowed to be these things. Okay, once I've written this with the restriction, now I can see if I can simplify the expression. So I see that there's an x in the numerator and x in the denominator, and they are factors, so I can reduce them. And I'm left with 1 over 2 times x minus 2. And I can't simplify this anymore, can't reduce anything anymore, so that's my final answer. So with my final answer, I'm going to restate the restriction. So our final answers, after all of the work that we do to simplify things, will always have the restrictions restated again. Okay, and that's the end of this question. Now, notice something. In the final answer, if x was 0 and I put that in the final answer, this final fraction does not go to undefined. The numerator, sorry, the denominator does not become 0. But we're still going to keep 0 as a restriction, even though it's okay for this final answer, because the restrictions refer to the original question. And in the original question, if x was 0, that fraction would be undefined. So we keep it. We keep it even though it doesn't apply to the final answer, because it applies to the original question. So I'm just going to make that note. It applies to the original. Therefore, keep all restrictions. Okay, let's do another one. So here's a more fun one. Now, I want to try to reduce this. I know that I see an x in the numerator and an x in the denominator, but the problem is that not every term has an x, so I cannot be dividing by x yet. So before I try to simplify this, let's first work on the restriction. So to get the restriction, best thing to do is to factor as much as we can. And I see there's a common factor down below of 2. Now I cannot factor anymore. I can now work on the restrictions. So the denominator cannot be 0. So I know that 2 will never be 0, so it's not an issue. The other bracket can't equal 0, so 2x minus 3 can't equal 0, otherwise the fraction will be undefined. So I'm going to have 2x not equal to 3. X cannot equal to 3 over 2. So that will be my restriction. X cannot equal to 3 over 2. All right, so I've written my restriction. Now I can try to reduce this. So you'll notice that the numerator has 3 minus 2x and the denominator has 2x minus 3. These two are not the same, but they are negative 1 times each other. If I put a negative in front of 3 minus 2x, I'm going to get negative 3 plus 2x, which is 2x minus 3. Anytime you have a difference and you switch the order, the answers are going to be negative 1 times each other. For example, if I say 10 minus 3 and 3 minus 10, this is 7 and this is negative 7. They're negative 1 times each other. 4 minus 6 and 6 minus 4 are negative 1 times each other. So same thing with the algebra. So this bracket and this bracket will actually reduce to become negative 1 over 1. So this is negative 1 over 2 is my final answer, but I have to restate my restrictions because even though there are no x's in the final answer, we can't have x's in the question at all because the x's 3 over 2 cannot be in the question at all because that would make the original expression undefined. Okay, a little bit more interesting, these ones. So to simplify this one, I cannot reduce x squared with x squared because x squared is not a factor of every term in the expression. So you cannot just reduce a piece of the numerator with a piece of the denominator. We can only reduce, I'm going to write this, we can only reduce with factors. And I'm going to put here not pieces. Okay, it's very tempting to say x squared and x squared will cancel, but they don't. What we'll have to do is we're going to have to factor the numerator and factor the denominator. So use your favorite factoring methods. This one is a simple trinomial. So we could do it just by picking the two numbers that work. Okay. And before I can reduce anything, I'm going to write the restrictions. I can see that x cannot equal 2. Restrictions are very hard to find until you factor. Once you factor, they should be clear. So here, -5 and -3. Those are the x's that will make the fraction undefined. So x cannot equal those. And now I can reduce the entire factor x plus 5 with x plus 5, x minus 2, x plus 3, restate the restrictions. Okay, next one, use your favorite factoring method. I'm just going to use my trial and error. And I want a negative y, so here's my -6y, here's my positive 5y, that will add up to -y. And we'll do the denominator. So, you know, with practice, you get very fast with the factoring. So here's my expression completely factored. Once it's factored, my next step is to write the restrictions. So I have each of these brackets cannot equal 0, so I'll just work a little bit on the side here. This 4y minus 1 cannot equal to 0. So 4y cannot equal to 1, so y cannot equal to 1 over 4. So y cannot equal to 1 over 4. And this one, y minus 3, can't be 0, so y cannot equal to 3. So let me just take this away. Okay, and now that I've written my restrictions, I can reduce the entire factor y minus 3 and y minus 3, and I'm left with 2y plus 5 over 4y minus 1, and y cannot equal to 1/4 or 3. And notice I cannot simplify this further. Just because I have a 2y and a 4y, I cannot reduce this by 2y because the other terms don't have 2y. Right? You can only reduce if every term has that factor. All right, and that's simplifying algebraic expressions, or in particular rational expressions. So I'm going to take you to the next page. We'll do a little multiplying and dividing. And so here we go. So with multiplying and dividing, we're going to treat these things exactly like fractions, like you learned to work with fractions in grade 7 and 8 and 9. The only difference is the fractions will have algebra. So just as a recap, how did we multiply fractions? So if I have 3 over 2 times 10 over 9, for example, multiplying fractions, we multiply straight across. So this would be 30 over 18, which can be reduced. I can reduce top and bottom by 6. So that would be 5 over 3. Another way to do this, which is much more efficient, is to say, because I'm multiplying straight across, everything in the numerator will stay in the numerator. So the 3 and the 10 will stay in the numerator. Everything in the denominator will stay in the denominator. So I can actually reduce across the fractions. You know, I don't have to reduce within its own fraction. I can reduce diagonally. So any numerator can reduce with any denominator, like that. And once I reduce like this, now when I multiply straight across, I'm going to have something that does not need to be further reduced because it's been reduced already. So we're going to use the same thing over here, and I'm going to start reducing diagonally. So this numerator with this denominator, the 3 and the 9. Now I see an a cubed and an a squared. I can divide both by a squared, leaving me with just an a up on top and a 1 over here. Now I have a 10 and a 2, so I can reduce this and get 5 and 1. The b cubed and the b squared can reduce to be b over 1. And now when I multiply everything, oh, you know what? We can't multiply yet because before we do anything, I should state the restrictions. So what about a and b? Neither of these fractions is allowed to have a denominator of 0. So that means a cannot equal 0 and b cannot equal to 0, right? Because neither of these fractions can be undefined. So now I can multiply straight across and I get 5ab over just 3. And I've got to restate the restrictions. Even though there's nothing in the denominator now, there's no variables in the denominator, those restrictions refer to the original question. question B. So very tempting now. I want to start reducing things, but we really can't because we have to reduce entire factors. So let me do the factoring and then write the restrictions and then see what can be reduced. So we're going to factor the top here, x plus 5, x minus 3 times x minus 3 over x minus 2. Now that we're factored, I can write the restrictions. So x cannot equal to -5, +3, and then from the other fraction, +2. Now that I've factored and written the restrictions, I can start reducing. So this x minus 2 in the numerator can reduce with x minus 2 in the denominator. Notice this only happens with multiplication. X minus 3 and x minus 3, and I'm left with x plus 3 over x plus 5. I'm going to restate the restrictions. Now I'm just going to rearrange them. In your final answer, always state the restrictions in increasing order. So from smallest to greatest. I'm going to make a note of that. In increasing order. Okay. And then that's it. That can't be reduced anymore. Remember, this x and this x, we cannot reduce them. The only way you can reduce something is if it's a factor of the entire numerator and the entire denominator, and then we can reduce them both. Okay, let's do division. So how did we do division with fractions? So I'm just going to do off to the side. If I have 2/5 divided by 14/15, what we did is we left the first fraction intact and we multiplied by the reciprocal of the second fraction. Reciprocal. Okay, and now I can actually do my reducing because now I have a multiplication. So I'll reduce denominators with numerators like that, and I get 3/7. And my final answer does not have to be reduced because I've already reduced. So let's go to question C. We can actually see, before I do anything, I can see that there's a restriction that C cannot equal to 0. I got that restriction already. Okay, because it's actually in both fractions. So now that I've written the restriction, I can start reducing. Actually, let me start, since neither of these fractions can be reduced right now, I can go right to the multiplying by the reciprocal. So multiply by 15c squared over 14a squared b squared, and now I can start reducing. So that 2 with the 14, the 5 with the 15. Now there's more, because this a with the a squared will leave me an a down below. This b with the b squared will leave me a b down below. The c with the c squared will leave me a c up above. And when I multiply everything together, I've got 3c over 7ab. Okay, now what didn't I do? I forgot. I forgot at this step that I have restrictions. I have new restrictions that happened when I took the reciprocal. So the a and b ended up being in the denominator now. So I have restrictions on what a and b are allowed to be. So a and b can't be 0, but also c can't be 0 because I had that from the previous line. So all three of them can't be 0. So as you find new restrictions from taking reciprocals, we add them to the list of restrictions that we had from before. Now I'm on my last line, and I'm going to state all three restrictions again. Notice there's no c in the denominator, but it's still in the restriction because it applies to the original question. Last one. So this one again is going to be with factoring x minus 5 times x plus 4 over, now how do you factor these two terms? X squared minus 6x. The only thing you can do is to common factor because it's not a trinomial and it's not a difference of squares, so I can just do this. Okay, now this fraction is divided by, and I'm going to factor these ones. I am not taking the reciprocal yet because what happens is I've got factors in the denominator right now that if I took the reciprocal, I would miss them. because I'd be flipping the fraction and I would miss them being in the denominator. So I want to make sure before I take the reciprocal that I have captured all of the restrictions so far. So x cannot equal 0, that's from the first fraction. X cannot equal to 6, but actually all of them have x cannot equal to 6. So now I've captured them all. And now that I've captured them, now I can take the reciprocal of the second fraction. So now turn this into a multiplication. X minus 6, let's get rid of this here, times x minus 6 over x plus 4, x plus 5. Okay, so x plus 4 and x plus 4 will reduce, x minus 6 and x minus 6 will reduce, and now I have x minus 5 times x minus 6 over x times x plus 5. Nothing else reduces. Remember, I can only reduce complete factors, and I have no factors that are the same now. So I'm just going to restate the restrictions. Uh-oh, I did it again. At the previous step, I forgot to restate the restrictions. I have more. At the time that I took the reciprocal, I had more restrictions. So I'm going to add to the list. First, I have my 0 and my 6 from before, but I also can't be -4, and I also can't be -5. So now, this is my final answer. I'm going to restate the restrictions. X cannot be equal to, and I'm going to write them in increasing order. So first -5, then -4, then 0, and then 6. Okay, so just to recap, your steps for simplifying when you divide, it's a little bit more steps, okay? The first thing you do is you factor everything. Then you write the restrictions. Then you take the reciprocal. Okay, and you write the restrictions again. Okay, look what happened. When my first expression had restrictions, and I wrote them, and then after I flipped the second fraction, I got new restrictions, so I need to add them to the list. Okay, and then after I've done that, then I can reduce at that point. So reduce. Okay, and then I can write the final answer. But I also have to restate the restrictions. Okay, so factor, write the restrictions, take the reciprocal, write the restrictions, reduce, write the final answer, and restate the restrictions. Okay, so all you have to do is remember that. All right, so basically for division, it's all about the factoring, and it's all about writing the restrictions as you go, because once you take the reciprocal, you might lose some restrictions because they won't be on the bottom anymore. Okay, so there you have it. This is simplifying, multiplying, and dividing rational expressions. Okay, thanks for watching.